Hello, this is for all my algebra students out there. So period 6 students and my extended algebra kids who are period 7, 8. There's nothing really here for you to do. You don't have to copy, take notes. I'm just hoping that you watch the video and things start making a little bit more sense to you. Last week you guys should have been completing Unit 8 lessons 6, 7, and 8. Lesson 8, probably the toughest of all of them. It was a word problem questions, which are always pretty tough. But for today, I'm just going to try and take last week's stuff and tie it all together and see if we could just make it make sense to you. So we got a little bit of review. Okay, the first thing is reviewing completing the square. And hopefully you remember that in order to complete the square, the first thing you have to do is just rewrite it and make space. So that plus 19 just moves way down here, out the way. Then you half it, which is -5. Then you square that -5 and get positive 25. So you add 25 and at the same time subtract 25. Now essentially we've done nothing to this equation because these two add up to 0. But these three are important to us because they are a perfect square, which means you can make one set of parentheses and say it's going to be just x. You keep the minus sign and half of that's 5. So that it represents this, and you copy everything else down. Now these two numbers actually go together. Alright, so -25 and a positive 19 adds up to -6. Now why would we ever complete the square on anything? Well, it helps us figure out the vertex point. And if you remember, parentheses lie, so that the vertex is going to be 5, comma, -6. That sign is the truth. This one is a lie. So I know where this turns around. Now I know a whole lot of things about this parabola. I know that the y-intercept from this is 19. I also know that this opens up because that's a positive 1 out in front, or the a value. So this opens up. And if it opens up, and the vertex is approximately 5, -6, that means over 1, 2, 3, 4, 5, and down -6. I'm just kind of estimating there. That means this parabola does something like this. So there's a lot of things that I would know by completing the square. Alright, now, this thing is wobbling a little bit, so I'm going to fix that. Alright, so the next one is completing the square again, but it's got a number in front of the x squared. And if you remember, you can't complete the square unless that's a 1. So your first job is the same. Rewrite this thing, make some space. This plus 35 is out of the way. And I'm going to factor this 2 out of both of these. That means I'll have a 2. And then I'll just be left with x squared. So this is like reverse distributive property, plus 6x. And I'm going to keep that space, and plus 35 is still out there. Alright, so we can now, because there's a 1 here, we can actually complete the square. So I can say half of 6, which is 3. I can square it, turns it into 9, add it, and subtract it. So again, 9 and -9 are 0. I've essentially done nothing, but I have created something interesting. That piece is a perfect square. So I should be able to write parentheses squared. Take the x, take the plus sign, and half of 6, and that's rewritten. Now, this 2 is here, we got this y equals. Now the question is that truly a negative 9? If you remember, we did 2 times negative 9, which is really negative 18, so that's kind of the trickiest spot in this entire thing. So y equals 2 times x plus 3 squared, and we are going to end up with a positive 17 out there. So we're able to figure out the vertex point of this because parentheses lie, so it's going to be negative 3, and 17 is the truth. This one, again, the a value is positive, same a value here, so I know that this thing opens up. And we also know some information. We know the y-intercept is 35. All right, so that's a review of completing the square. And I got a couple more here. Okay, so they also tried to work on finding zeros of a quadratic equation. Now the zeros of a quadratic equation, you simply follow this. If you want zeros, you set the y value equals 0. So I'm going to put a 0 exactly where this y value is, but you know, because most of us are right-handed, I'm just going to turn it around so the 0 is over there. So I'm going to follow these rules. You know, I'm going to factor the left side once it's equal 0. This type of factoring looks like the unfoil. Okay, it's got the 3 terms, and there's no GCF, so I'm just going to go with the unfoil parentheses. X times x is how you guarantee that to happen. And things that multiply to be negative 8 would be like negative 4, positive 2. So I test them, negative 4, positive 2, and I think I've got it. I think that now the outsides are a 2x and the insides are a negative 4x, which are going to add up to negative 2x. So that is the middle term. So everything's guaranteed there. We can move on. Now I'm using something called a zero product law, and I'm sure that Kirk taught you about that. That if you multiply 2 things together and they equal 0, well, one of them has to be 0, or perhaps both. That's where he has you split it, and he says take this x minus 4 and make a little baby equation. Take this x plus 2, same thing, make a baby equation. And you solve these. Alright, so undo this plus 2 by subtract 2. So one answer is negative 2. Over here you get another answer. Add 4 and x equals 4. Now these are what are called zeros. That means that when this parabola is graphed, it's going to hit the x-axis at 4 and hit the x-axis at negative 2. So these are basically x-intercepts. So the word zeros and x-intercepts are the same thing. Okay, so let's move on down to number 2. If I wanted to find the zeros of this thing, keep it simple. I'm going to put a 0 where y is. Again, like I said, a lot of people don't like to see the 0 on the left side, so I'm just going to put it on the right side, no big deal. Now remember, there's 3 kinds of factoring. Remember, the first kind you got to try is always GCF. The second kind is ask yourself, maybe is it DOPS? And then the third kind, is it an unfoil, a trinomial that can be taken apart? Well, this one, if I start at the beginning and look for GCF, you notice they're both divisible by 2 and they both have x. So GCF, I'm going to take a 2 and the lowest power of x is x. And if I take a 2x out of this, I'll be left with an x minus, and I'll be left with a 7. You can always check yourself by redistributing it and make sure it goes back to being what you had before. Now the same rule, zero product properties in play. this 2x times that parenthesis, and the answer is 0, well, one of them's got to be 0, guys. So you just set them. Take this 2x, set it equals 0. X minus 7, set it equals 0. Over here, 1 move, divided by 2. 0 divided by 2 is just 0. Over here, plus 7, plus 7. X is 7. Okay, so what are we saying about this parabola? I'm saying that if you graph it, it's going to hit the x-axis at 0, and it's going to hit the x-axis at 7, and that's that. Now, I do know several other things. I do know it opens up, and I do know the y-intercept. You don't see it, but it's there. Plus 0. Hits the y-axis at 0. Oh, 0, 0. All right. Keep them moving, kids. All right, so I got a couple more here. This top one, if you're looking for the zeros of this, the rules shouldn't change. You should put a 0 y is. X squared minus 49, and again, I'm going to put it on the right side. So you have the 3 kinds of factoring. There is no GCF. But it does look like dots, because I know the square root of this and the square root of this. So you can always get the 2 parentheses out. One's always plus, one's always minus. The square root of x squared is just x. And square root of 49 is 7. Same rules, 0 product property. Split it. Set each one equal to 0. And solve each side. Now these are called factors. The author of the book is making a very good effort to try to get you to see the difference between the actual answer and the factors. Now the factors, which happen to be in parentheses, x plus 7, well, the actual 0 is x equals negative 7. And if the factor was x minus 7, well, the 0 is x equals 7. So there's a connection between factors and zeros. If you know what the factors are, then you automatically know what the zeros are, and it crosses the x-axis at negative 7 and positive 7. All right. This next one, number 4. Same rules. Okay, let's rewrite it. This one looks hard. Okay, but we can do it. Equals 0. That's how you find zeros. Is there anything common, a GCF, that divides into all 3 of these? Well, I happen to know that this is divisible by 3. All 3 of them are divisible by 3, but no common letters, so just remove the re. You'll be left with x squared minus 4x minus 21. And the rules about factoring, can you keep going? Well, this part in here, that looks like an unfoil. So, of course, you can't disrespect, so 3 is still there. So we're going x here, and things that multiply to make negative 21 are going to be minus 7, positive 3. These outsides are 3x. These insides are negative 7x, which add up to negative 4x. Okay, that's good enough. So there's actually 3 things. This times this times this, and the answer is 0. So one of them, or all 3, could be equal 0. So you could literally write 3 equals 0, but everybody knows that's ridiculous. So we ignore that. But x minus 7 could be 0, or x plus 3 could be 0. And you do your algebra moves and figure it out. So one answer is 7. The other answer, and remember the opposite, so we got a 0 of negative 3 over here and a 0 of 7. Now the book makes also this effort to write the answers as a solution set, and you got to use those fancy braces. If you want to do that, you can say 7 and negative 3. That means this is roster notation. This is a list of answers. All right, so these last couple I just have written different. It says find the solutions. Well, I follow the rules. Look for GCF. Both are divisible by 5. But they both have x, and the lowest power is x. Alright, imagine a 5x removed. From this, you'll be left with 2x, and a 5x removed from that would be minus 5. And then you treat it the same. This 5x times that parenthesis, and the answer is 0, means one of them is 0. So figure it out, kid. Divide by 5. So one answer is x equals 0. And the other answer is actually going to be more complicated because it takes more than one move to get the x alone. So no big deal. Do it. So x equals 5 over 2. If you want to make that a decimal and say 2.5, I could care less. You're fine with it. All right, so number 5 is done. All right, and one last thing before I let you guys go here. Just remember that zeros are solutions to quadratic equations. They are the same as the x-intercepts. So when we graph a parabola, there's only a couple of important things. Where does it hit the x-axis or the y-axis? That's important to us. Where does it hit the x-axis? That's important to us. Where does it turn around? The vertex. That's important to us. So a vertex can be found by completing the square. Okay, we saw that on our first couple of questions. These zeros can be found by setting equal to 0 and then factoring and solve. This y-intercept, well, that's just the ax squared plus bx plus c. Remember that c is all automatically that y-intercept. So we know a lot of things about these parabolas, and that's what they were trying to get you to understand in the couple of videos. So I just wanted to send something out to you guys. You guys should be starting a review tomorrow. I think you got to do 1 through 19 or 20, all the multiple choice basically has to be done tomorrow. And then the next assignment would be check the website. But stay current, kids. I will be putting a Castle Learning together for Thursday, Friday, so you have 2 days to complete a test. I hope you guys are keeping up. Please email me videos. If you need anything worked out, I can help you out. I can post videos. All right. Take it easy, guys. Stay healthy and stay safe.